In this example, we are going to use Newton's second law to solve the acceleration of the object. We have an object that has mass of 5 kilograms. It will be sliding on the inclined plane. The angle of this inclined plane is 30 degrees. The distance from the box to the ground is 4 meters. So the question is to find the acceleration of this box, the speed of the box, knowing the inclined plane is rough and the coefficient of kinetic friction is 0.25. The first thing we need to do is the free body diagram and then use Newton's law to find the acceleration of the object. This object is under the weight, mg. The normal force is perpendicular to the surface where the object is located. mg is perpendicular to the ground. Then we have friction force is on the surface. So by definition, the friction force is against the motion. The object will be sliding downward. The friction force is in opposite direction of motion. If we shrink the object, to see clearly the direction of forces. So this is 30 degrees. This is normal force. This is friction force, mg. We know mg is 90 degrees. This is 30 degrees. This must be 60 degrees. So if we need to choose our reference, x and y axis. X-axis is in the direction of motion of the object. The y-axis will be perpendicular to the surface. We have three forces. Now, with Newton's law, we say sigma F equals to the mass times acceleration. This sigma F has a coordinate on x, which is sigma Fx and sigma Fy. Sigma Fx, if this force mg has coordinate on x, we drop mg on x perpendicularly, it will be mgx. Mgx will be mg cosine of 60 degrees or mg sine of 30 degrees. We have friction force on x-axis. Also, we have mg in vertical direction, which is mgy. Mgy will be this. If this is 60 degrees, this will be 30 degrees. So mgy will be mg cosine of 30 degrees. So what we did, we drop the coordinate of the force mg on x. We get this horizontal component, we call it mgx, and we dropped on vertical direction mg, we got mgy. We said this angle, if this is 30, if I take this triangle, this 30, this 90, because we know mg is perpendicular to the ground, this angle should be 60 degrees. So this is what we say. mgx is mg cosine of 60. Now we go to our equation. Sigma fx is mgx, which is mg sine of 30 degrees minus friction force equals to the mass times acceleration. In vertical direction, we have normal force minus mgy, because it's downward. This Fn is upward, is positive. Mg is downward, is negative, mgy. Mgy, we said, is mg cosine of 30 degrees. And the sum of the forces on y direction is 0, because the object is sliding on x direction. There is no vertical motion. So there is no motion of vertical direction. This is why the acceleration on y direction is 0. So the normal force is mg cosine of 30 degrees. So remember, the friction force by definition is the coefficient of friction times normal force. This we need to remember. And this friction force, in this case, will be the coefficient of friction times mg cosine of 30 degrees. We go to x-axis because we are looking for the acceleration. We go back to x-axis and replace the friction force. We said mg sine of 30 degrees minus friction force, which is negative mu mg cosine of 30 degrees equals to the mass times acceleration. The acceleration in this case, if I take this mass out because it's in common, the acceleration will be g factor of sine of 30 degrees minus mu cosine of 30 degrees. Now the acceleration equals to 9.8 meter per second squared, factor of sine of 30 degrees minus 0.25 cosine of 30 degrees. Now the acceleration should be 2.78 meters per second squared. Now we need to find the speed. Remember, we said the object is started from rest, the initial velocity is 0, and we have this distance already. We said it will move down 4 meters. So we need to find the velocity at the bottom. We have the velocity squared equals v0 squared plus twice acceleration times delta x. We know v0 equals 0. That means velocity equals plus or minus square root of 0 squared plus twice times acceleration, which is 2.78 meters per second squared times delta x, which is 4 meters. So remember these equations we used in kinematics. If you go to the video of motion in one dimension, you will see more details about how we got these equations. We have two solutions, plus or minus 4.71 meters per second. But if we look to the motion of the object is going downward, this is the direction of motion of the object. So in x positive, that means the direction of velocity will be on the x positive. In this case, we will have just the plus value. So the velocity of the object will be plus 4.71 meters per second. Thank you.